Next up is integrating IoT edge devices to optimize legacy assets at the well site. And coincidentally, that's me. So, easier transition there. And I have a co-presenter with me as well. His name is Bryan Hendricks. He is going to be our first digital or remote presenter for the day. So I have, and I can see he is locked and loaded, ready to join us. So whenever the PowerPoint comes up, I will go ahead and kick this off. You know, since my company is a software company, we often have competitions to see what the best variable name will be if we're going to do a while loop or something. And you know who won? I did. All right, I'll brush it up for the next day, okay? All right, here we go. So today's topic is integrating IoT devices to optimize the well site. And we're going to explore this topic by looking at a case study from a producer called PureWest and technology from AUTOSOL. So for those of you who might have missed the opening of this, hello, my name is David Blanco. I'm the Director of Technical Operations and Business Development for a company called AUTOSOL, based right here in Houston, Texas. AUTOSOL makes industrial automation software that is used heavily in the oil and gas space, and we've been in business for 35 years. In this particular case, AUTOSOL played the role of vendor. So I'm going to very briefly talk about two products we have that are relevant to understanding the success of this case study. AUTOSOL has 9 software products on the market now, 2 of which we used for this case study here. On the top left, you see highlighted AUTOSOL Communication Manager, or as we like to call it, ACM. This is a server-side multi-protocol polling engine that brings back real-time and historic or EFM data, publishes it out to historians, HMIs, measurement systems, etc. Then we have in the bottom left there, wait for this, eACM, Edge ACM, that is a lighter weight version of that is deployed in the field on edge devices. And I'll go into more detail about that as it's relevant throughout the presentation. My co-presenter is Bryan Hendricks of PureWest. He is the Oil and Gas Automation Manager. His role in this was that of the individual who identified the issues PureWest faced, selected the technology, and then successfully implemented that technology on his SCADA system. And a little bit here about PureWest real fast, because they are a relatively new name company. PureWest Energy is an independent natural gas company focused on development in the U.S. Rockies with current operations in the Pinedale, Anticline, and Jonah Field in southwest Wyoming. PureWest is the combination of Ultra Petroleum and Pinedale Energy from, I believe, last May. So here's the agenda for today. Very quickly, I'm going to give the AUTOSOL PureWest interpretation of what IIoT or digital transformation is to make what we did sound relevant to what we do every day at our jobs. Then I'll go over some of the preliminary project details. I'll pass it over to Bryan, who'll give you his experience actually doing a large-scale, I'll say, digital transformation of his existing brownfield assets, some lessons he learned, some things he liked, some things he didn't, and then I'll very briefly conclude, and we'll open it up to a very rigorous, I will call on you anonymously Q&A. So what is IIoT or digital transformation? Here is the definition I have seen at a lot of other shows, including literally this one, I think, 2 years ago. Digital transformation is the cultural, organizational, operational change of an organization, industry, or ecosystem through a smart integration of digital technologies, processes, and competencies across all levels and functions in a staged and strategic way. What a loaded definition. All competencies, all levels, your intern and your CEO. How do we even begin to use this in our daily lives? How do we pitch this to someone internally and say, hey, I'm the SCADA manager and I think you should do this? Well, I'm going to poll y'all a little bit here. Okay. Who here has started a digital transformation project? Please raise your hand. All right, good. I expected more for this kind of show, but that's fine. Who had to integrate new solutions alongside their existing infrastructure? Basically, who had a brownfield experience? All right, a majority of people who raised their hand last time. Who got to rip and replace absolutely everything and start from scratch? We should talk after this. Now, who had full cooperation with all levels at all times for all things? Okay. So now that we've kind of established a baseline that our experience was similar to yours, let's actually make this something that we can work with. So to take all the marketing fluff out of it, digital transformation is really the operational change of an ecosystem, SCADA system, through a smart integration of digital technologies in a staged and a strategic way. Or as I like to say, unlocking potential through software. Now, we can apply this directly to PureWest and get results, and that is what we did. So at PureWest, we had operational challenges that existed in the SCADA system. We applied new software and hardware to the existing system, and we positioned them for strategic growth, and that growth has two layers. One is the physical growth, the acquisition of new wells, and integrating them into the existing system without forcing a re-engineering of everything every time. And the second is growth on the digital transformation business side. If they want to connect, Ambient has been thrown around here before, when they wanted to connect Ambient to their system, they didn't have to re-engineer their whole system, they just had to talk to the broker. So there's two layers of growth here when I say growth. So what were we working with? Well, they had a traditional HMI that was doing the demand and the response for their polling built into it. It was doing real-time and EFM collection, and it was bringing back about 350,000 tags across 400 FGR radios that on a good day, when the sun was shining and there were no pine trees growing, got 700 kilobits a second through. And it was talking to about 1,000 RTUs and PLCs, roughly even split between SCADA packs and ROC 800s. The issues that PureWest identified they were trying to overcome the operational challenges to relate to the definition were these. The best poll time they can get was 17 minutes. The worst poll time was 60 minutes, and the worst of the worst was that 30% of the data just didn't even come back at all. So 17-minute poll time to 1 hour with 30% missing data. There was also no ability for them to remotely manage any of the devices they had deployed in their field either, the SCADA packs, the ROC 800s. And what really was the straw that broke the camel's back was that their existing SCADA system hit that point where it was no longer enabling growth. It was going to prohibit them from being able to see the kind of growth or the returns that they wanted to see. So the goals of this project were these. 1, decrease network traffic in order to get higher resolution data for optimization, specifically for gas lift and plunger wells. Also be able to backfill data if and when there is a COM outage, so that way the optimization programs can still run properly. So these are the technologies that were chosen for this transformation. First, on the server side, a name we were pretty familiar with, so I won't go into too much detail about it, Ignition, selected for its ability to handle MQTT information successfully. The other one was ACM. This wasn't revolutionary, but it was new for them. Basically, this is how they wanted to get their EFM data back from the field. And where a lot of the work went into is on deploying eACM, or Edge ACM. This was deployed in the field to bring that MQTT from the field back up to the server, to decrease that bandwidth because of the MQTT usage, the report by exception, and then get them higher resolution data for the tags that they wanted, as well as do backfill when comms went out, feed it back up to the Ignition system and all the other MQTT clients. So let's build a picture of what the ideal solution was going to be according to PureWest, right? And we'll start where I'm already talking at eACM. You've got eACM in a Linux environment on an IoT device deployed in the field. From there, eACM can talk to multiple RTUs or PLCs at the same time in their native protocol as they're already programmed, convert that to MQTT and bring it back up to a broker where multiple MQTT clients can consume that data, and alongside that sits ACM to do the EFM collection. So real fast, there were also two pieces of eACM that were utilized in order to cut costs and better optimize the system. One is a software that's built into eACM called Priority Forward. It's a glorified software traffic cop. You can put eACM in front of a serial device, and Priority Forward lets you still communicate to that serial device automatically if eACM is in front of it without manually shutting anything off. And there's also a server-side MQTT communication-enabled management software that lets you discover and manage deployed eACMs. And here's a quick screenshot of what that looked like to prove it exists. So here was the hopeful timeline, right? Nice and easy, bow on it. We're going to start it, we're going to finish it, we're going to buy it, we're going to deploy it, we're going to integrate it, and we're going to use it. Let's roll. Well, like every good plan, eventually the tires have to roll, right? And here's what the timeline actually looked like. So we do a test lab of eACM, looks great. We do a field deployment, 1 or 2, a pilot. We install ACM, make sure it does what they want to do as well. Then we were hit with the chip shortage last year. This was May 2021. So the hardware we originally picked was not going to be able to scale as fast as they wanted it to for their, March to July schedule. So we had to pivot and pick a new hardware. Then we had to go back and reinstall it, make sure that everything worked, have some little back and forth about, well, here's what this feature does. Oh, that's what you meant by you needed that. And then we hit the learning curve. Now, there's a lot happening here, and I'll go into a little bit of it right now. And in my mind, this is what we're really here to share, right? So first off, the integration side. With every new HMI, there's always learning curves, training issues, what you thought it meant in the demo and what it really means in your system. And so with the switch to Ignition, it went well, but as always, a learning curve. Also, there were, I see Evan's here, there were a lot of expectations of how MQTT functioned, but then a lot of missing features from the traditional demand response world. And then eACM itself. So prior to this, eACM had been deployed on a maximum of 3 devices with a test lab certified ceiling of 10. But of course, our test lab is not robust as a field. So as the project went on and we were deploying to sites that required 15 device connectivity, the original plan was, well, we'll slap 2 devices out there with 2 ACMs, one with 10, one with 5. But the chip shortage undercut that. So we had to go and enhance our product in relation to what was actually happening in the field and raise our ceiling 50% from handling 10 devices to handling 15 devices on the same specs that we thought we could handle 10 on. And we were able to do that successfully. We also added a lot of things that were reminiscent of demand response. We added a lot of COM status tags. So yes, MQTT is report by exception, but a lot of that stale data made people uncomfortable or nervous. So we added COM status tags. We're like, hey, sure, this value didn't change, but here's the last good poll time from the actual device. So they're still able to know, okay, this is static because it's just not changing, not because I lost communications. We added demand groups, so that way a user can still click that lovely demand button and get an instant poll and republish of all data or just specifically grouped data. So that way they still felt in control despite the fact that the system is largely a set it and forget it report by exception system. We also added a lightweight web page to handle the 700 kilobit network and an automated remote upgrade application to push these changes that we made to these new devices as these issues came up. And of course, they wouldn't put it in writing, but, a bug or 2. Covered by Bryan there is also, I think, a date that we actually started using ACM on the system. Up Energy also became PureWest Energy was made from Ultra Petroleum as they acquired Pinedale Resources. That always adds a week or 2 to any project. They also moved offices twice, but I only had the email with the date of one of them. And of course, the very last eACM license was installed this past December 14th, 2021. Which brings us to today. What does the system look like now? We have Ignition talking to 1,000 devices with 400,000 tags. The original HMI is still there, but only until Ignition is 100% ready, which that's not my job. I'm the vendor, not the integrator. And then eACM is there. There are 250 eACMs on 250 edge devices talking to 1,000 RTUs and PLCs, bringing back 350,000 tags. And ACM doing EFM for those devices as well as some time sync functionality. So here's the ideal system we were going for initially, and here's what it looks like now. So the goal and the reality align pretty well. Everybody has a little more robustness built into them as a result of this experience. And now I'm going to go ahead and stop talking and let Bryan relay some of his lessons learned and experiences. So, Bryan?
Thank you, David, for allowing me to present with AUTOSOL today. I want to share some of the story that surrounds our digital transformation to edge and processing at an edge environment. When PureWest began operating about a year ago, we were getting about 17-minute data resolution for a small portion of our field. On average, for the majority of our field, it was about 60 minutes data resolution. And when management came in, they asked for a 1-minute data resolution from our entire field. And we also needed to address reliability issues. Our data not only was coming in at every 60 minutes, but it was very unreliable. The data would either just not be present or it would be delayed in its arrival to the servers. And so we knew we needed to address a reliability issue. And we also needed to address an issue of outages. If we suffer from a network outage, then we would constantly have gaps of data. We'd have information that would just simply be missing, and we kind of got used to not being able to do anything with that data. And so we wanted to address all of those concerns with a digital transformation into a different technology. And so we started looking around, and AUTOSOL was one of the first that came up to the very top of the list. They were a leader in MQTT and oil and gas. A lot of the vendors we approached had something in the works, but it was nothing that you could purchase off the shelf at that time. And so AUTOSOL had products that were available right then and there, had already been deployed in the field. And so we also had a history with AUTOSOL. We've used their ACM polling engine in the past. And so we had a comfort level with AUTOSOL. So it was quickly decided that we'd go with an AUTOSOL product. Now, I'd never heard of MQTT or edge devices. Edge sounds really neat. It's a technology that you probably want to put in your network and make everything faster and better. And so I began the process of learning what MQTT was, what edge devices were. And so it was quite a steep learning curve for me when I first began to go down this path. I want to discuss what we found through this process, some of the good and some of the challenges that we faced as we went through this. MQTT does deliver 30 to 70% network performance improvement. It's one of their big things they stick out there. Hey, we're going to save your network 30 to 7% just because we do a publish on change and not the stereotypical SCADA pull and response kind of mechanism. And it does deliver that. MQTT does deliver a very efficient publishing mechanism where you're only using your bandwidth to get data to your servers once they've changed. And so that was one of the first things we noticed was an improvement on network reliability. And that was kind of like a checkmark box. We could say, yep, works as advertised. And so one of the other things they do is edge devices provide you with backfill. And so depending on how large of an edge device you choose, edge devices are just simple computers. I had to learn that. It's just literally a Linux-based machine that has a CPU, memory, hard drive space, interface, and you just put this out in the field now, out by your oil and gas well sites. And so, and then you use your hard drive for backfill. And so we discovered quickly that, yep, it's going to use backfill. And so we were able to deploy that for our solutions. Many who have Fisher Rock devices probably rely on histories. And that's a really good way to bring data in from an RTU. But if you're dealing with a PLC, or if you're dealing with a SCADA pack and you don't have like a D-log or a history already created, then you're going to find yourself limited on a backfill option. And so that was us. We had a lot of SCADA packs that had no D-log set up, and it would be expensive or time consuming for us to build that. So the edge device had the backfill, and we looked at, hey, that's going to be a great solution for that problem. So I do believe that that is a very good function of edge devices and MQTT. They know when there's going to be a network outage. They can kind of communicate, see that's happening, start to store the data, and when the data can resume, it starts firing that data off, and you can catch up and backfill back to your servers. Coupled with 30 to 70% efficiency, it's a great way to deliver data when it's been lost. And so it's a great way to fill in the gaps if you have a network outage. So another gold star for MQTT. It works as advertised. The publishing to a broker is something new as well. We've never dealt with that before, is having a broker. You don't have to have a broker, but in our case, we did use one. We did find out it adds flexibility. You have the ability to kind of like toss your data left or right, and get it to other sources like a Kafka server or other brokers or to the cloud and be able to push data to the cloud. And so the broker did add flexibility to what we were doing. And so that was new as well. We'd never dealt with a broker. And so all of these things were really good things. Advertised MQTT does it. But as we begin to work through this process, we begin to deal with the unexpected results, the unexpected drawbacks from MQTT that we never thought of before. And I want to go over a few of those. The first one being that if you're deploying MQTT over low bandwidth, and that's where this 30 to 70% comes in. Oh, you'll save all this bandwidth. What they don't tell you though is that you're going to have to administrate all these edge devices. So here you have a Linux operating system. You've got a piece of hardware that requires firmware. You're going to have a configuration for that Linux device. You're going to have the application you're running. In our case, eACM. It's an application. It requires updates. Configuration for the eACM also needs done. And we found out that those are large files. They're several megabytes in large each. And we have 245 edge devices deployed in our field. So we quickly found out that trying to administrate a large amount of firmware updates or application updates over a bandwidth that's low is not feasible. And so we were thankful that we did do a broadband upgrade parallel to our complete replacement of our SCADA systems. And so we were able to overlook this drawback. But if you're planning on running MQTT or edge devices over a low bandwidth solution, network solution, then you're going to find this very limiting. Yeah, it's going to be very difficult. You have to shut down your entire SCADA network, stop polling, stop publishing in order to try to push updates to your devices. And depending on how many you have, that could be very detrimental to your network traffic. So that is a drawback that you kind of don't think of. AUTOSOL did try to solve this for us, where they did deliver a low bandwidth web interface page. And that was helpful. You can get on there and make manual changes. But if you had to upload 10,000 tags, you probably don't want to do it across a web interface like that. You'll want to upload it through an import process. And so we do find that very limiting across low bandwidth networks. The next thing is that data is not just data. You'll find that out quickly. You'll find out that there's different forms and types of data. If you're looking for real-time data that's unrelated to any other piece of data, then MQTT is your friend. Every value as it's published is going to get its own timestamp, and it's separate and different from other data. That works as advertised. In our world, for oil and gas, we have plunger lift operations, and those records come together as a related group of data. You want to know what your tubing casing flow rates are when that plunger arrives. So you have what's called a plunger record, and you want all that related. Well, you need to have a shared timestamp or some way to identify those records together and say, I am an arrival record. And that's a huge part of oil and gas for a producer when you're trying to optimize your wells with plungers. And MQTT does not solve this one bit. All of the data is unrelated. They all get timestamps that are different, several seconds, even minutes apart from the other changes. And we found no way for us to re-relate that data into a record, into a data set after it arrives through MQTT. So we had to abandon that portion of our development and just go back to using D-logs from our SCADA packs and ACM to pull those data. And it does handle it now as a record going through that mechanism. The last thing that finds out is this complicated. The last drawback to edge devices is that you are adding layers of complication to something that was relatively simple in the past. If you're dealing with a centralized SCADA server and you're doing polling or you're looking for data, you're dealing with one server and you've got all your tags that are built up into it, and you can kind of do what you need to do to troubleshoot that. Essentially, what you're doing with edge processing is you're moving the polling engine into the field. And now you have all of that polling, the tags, the configuration for that out in the field. And you're going from one centralized polling engine into dozens or hundreds of devices now that handle that polling. In our case, we have 245 edge devices in the field. I think upwards of 250 now. And so when you go from one centralized polling engine to 250, you're adding a layer of complexity there. Plus, you have to start to rule into the impact that the Linux operating system has on polling, hardware difficulties or firmware issues. And we've had some of those. We've had bugs with hardware that was causing polling not to work properly. We've had Linux problems that caused the hard drive not to store data properly. And so the broker, we've had issues with the broker and had to, figure out why it wasn't working properly. So the main thing about edge processing is that you are adding complexity to a system that is relatively simple as it is now. You go in, you set up your comm stations, you got your tags, you start polling, you're done. And so that was a drawback in our world because it's a learning curve. Number one, you're learning a very large brand, a broad spectrum of devices and hardware and all of those kind of things. But then you're also adding to the complexity of the maintenance that goes with it, the configuration that goes with it. And it's almost 2 to 3 times much more complicated than it was under the previous polling mechanisms. So those were some of the drawbacks. I don't think it's anything that's hugely detrimental to MQTT as a technology, but those were things I wasn't aware of when we went into this project. And so I will say that because of the complexity, because of these moving parts, it's very important that you have a vendor that supports you. You've got somebody that understands this, understands oil and gas, understands your industry, and can help you kind of get through that process of getting Edge or MQTT to work in your environment. And AUTOSOL has been that vendor for us. They've done a lot of custom scripting. Because of the size of our project, they quickly identified that we would need the ability to administrate, roll out large groups of configuration or updates on an automatic process. And so they've built custom things for us. They were very responsive for that. They've been developing their eACM platform with many of our requests in mind and trying to roll those things out. And they've also been kind of ahead of the curve. Before we asked for some features, they'd already had them in mind. And so AUTOSOL has definitely been a partner in this transformation for us to get from point A across the finish line. So I hope that helps with the complexity of MQTT and edge devicing and how it applied to our project. David, thank you, and I'll toss it back over to you.
Thank you. So we are a couple minutes over. I'll go through this conclusion slide real fast and just get to the part I like. Basically, a good takeaway here is that while, for example, Bryan did say that they ripped and replaced their communication network, as far as I know, and Bryan can interrupt me here, the RTUs and PLCs are the same RTUs and PLCs that were there originally. And so it turns out that you can, in fact, teach an old RTU a new trick. And that's what we did here, right? With, as he mentioned, the priority forward, that was just 50 of these 1,000. That's $250,000 saved by being able to connect to them simultaneously without having to rip and replace the RTUs and PLCs. So at least in my experience, I know it differs across the room, but I see a lot of potential for brownfield to be optimized without having to lift everything in the field or re-engineer everything. And with that, let's go ahead and open up to Q&A. Any questions, comments? So an anonymous internet user that I didn't have time to think of a cute name for asked this, and that is, to what extent can IIoT be used to implement functions realizing well automation? Bryan, do you want to take a crack at that first, or shall I?
Go ahead.
Okay. I think that for this particular case, anonymous user, eACM was used as a data collection tool, primarily, data handling tool, protocol conversion tool, and there is a third-party application. Let me see. Oh, I'm doing it on my laptop as if that's going to do anything. I don't know if you can still see the PowerPoint, but I'm going back to one of our slides that has the system that was actually deployed right there. Hooked up to the MQTT broker is now a third-party optimization application. So the optimization software does sit on the cloud, and this system has been transformed from the traditional demand response. I'm going to have to daisy chain my data to get it out of this proprietary SCADA system to opening it up. So now when they decided, hey, let's toss on this, as if it was flippant, let's just add this optimization software to the end of it, they were able to do that without having to go back down and rework everything. So hopefully that answered the question. And it looks like we have 3 minutes left. Yes, sir.
To the benefit of everybody in the room, heard a lot of MQTT generalization as far as moving data. Can you speak to this project where they use JSON payloads, Sparkplug payloads, and maybe just real quick, what's the difference, advantages, disadvantages?
Yes, very briefly. And I guess my apologies for putting in my presentation and not giving a baseline explanation. For those at home, the question was, can we explain some nuances of MQTT? Yes, real fast. MQTT is a way of transporting data in a report by exception model. So basically, I have an MQTT in the field. I send it up to what's highlighted in green here, a broker. And what that means is I can have, in theory, unlimited number of publishers of MQTT to this broker, and then any number of clients behind that broker to get data. It's a way to share data as, I believe as Evan said, data is now infrastructure rather than just locked in. This project, or eACM, only uses MQTT Sparkplug B because that is the standard that is steered by the committee that Todd is on. And basically, if we, out of the box, say, oh, I'm Sparkplug B compatible, and Pi says, oh, I'm Sparkplug B compatible, we can talk. Otherwise, MQTT is just a proprietary packaging of data in some JSON format, and where I put the metadata or the value might be different than where this software receives it. So this project used MQTT Sparkplug B because that is the standard, and it lets you also transport blocks of data. Like when I send backfill up, and I have 100 pieces of data, I'm not sending 100 messages really fast. I'm sending a block of message and saying, here's the current value and here's 99 historic records. Do what you do, MQTT client. So that's some of the nuanced differences and advantages. I hope that answered the question. Okay. 30 seconds left. Questions, comments? Nothing online, so thank you all very much for your time and attention.